seeing some more Boolean logic theorems, that is a distributive property and absorption theorem. Right, distributive property, just like as in your maths, x into y plus z equal to xy plus xz. By taking the dual of that expression, what do we get? Dot को plus बनाना है, plus को dot बनाना है, ठीक है? So x plus yz equal to x plus y and x plus z. Okay, so that is what the distributive theorem. And right, next absorption. So one variable is absorbed by the another one. Okay, so that is absorption theorem. Now if you see, no, x plus xy is x. The final result you will get is x. So y is absorbed by x. Got it? Okay, and if you find the dual of that, that also will hold true. So now quickly draw truth table for these expressions. First one, distributive theorem prove karo using truth table. Prove distributive theorem. Prove distributive theorem using truth table. Are you all doing? Yeah. So whomever I'll ask, you turn on your video and show me. Truth table. So now how many variables we are having? 3 variables. 3 variables means how many combinations we should get? 8 combinations. So we need y plus z, we need xy, xy, xz, x plus. Okay, have you all started? What are you all doing?
Yes, ma'am.
Yeah, quickly do. Y plus z is 0, x into y plus z is 0, xy is 0, xz is 0, and this also 0. Now combination is 0, 0, 1. Now y plus z is 1, x into y plus z is 0 because 0 and 1 is 0. Next xy is 0, yz is xz is 0 and total 0. Taken. Next combination 0, 1, 0. Okay, so y plus z is 1. X value is 0. So x and x, wherever x and is there, 0. Okay. Next 0, 1, 1. So y plus z is 1. X and, so x value is 0, 0 and anything is 0. Okay, ma'am. So now 1, 0, 0. So y plus z is 0. X and y plus z is 1 plus 1 and 0 is 0. Xy is 0. Xz is 0. Xy plus xz is 0. Now 1, 0, 1. Y plus z is how much? 1. X and y plus z is 1. Xy is 0. Xz is 1. So total is 1. 1, 1, 0. So now y plus z is how much, children? 0. X and y plus z is 0. Xy is 1. Xz is 0. Xy plus y is xy plus xz is 1. Correct, na? See, y plus z is 1 here. Y plus z is 1. X and y plus z also 1. Okay, xy is 1. Xz is 0. 1 plus 0 is 1. Y plus z is 1. X and y plus z is 1. Xy is 1. Xz is 1. Xy plus xz is 1. Now if you look at this column, that is x and y plus z, then xy plus xz, both should be same. Okay, so here this column okay, and then this column, both are same or not? Observe, children. Again answer. So hence proved. First theorem is, first part is proved. Now you prove the second part. Whenever you are proving using truth table, both should be there. Okay, this is the first part. Finished, children?
Ma'am, what is
Yes,
the
ma'am.
last column, ma'am?
Last column will be x plus y and x plus z, na? Have you all completed, children? Now can I ask? Ready, children?
Yes, ma'am.
Okay, I'll make you presenter. You turn on your video and show. Anyone else also completed?
Yes, ma'am.
Finish quickly. See, this type of questions will come in the examination, children, compulsory. That's what I am giving you time to solve. See, now in the previous class, I taught you how to, and now also I taught you one question, one part of the distributive theorem, right? Other part. How many of you finished? Raise your hand. Only one person has finished. Very good. Two people have finished. Very good. Aditya and Simran. Yeah. Akila also finished. Good, good. Harsh also finished. Dimple also finished. Very good. No, remaining all not finished. Bhuvaneshwari today she has not joined class. Irfan. Okay, so now I'll make Aditya present. Quickly you show me. Or you can turn on your video also and show. No need of making.
Yes, ma'am.
Yeah. Yes, ma, show me.
Am I able to see?
Yeah, very good. Now can you, but this column you left it blank, no, last one.
No, ma'am.
Is it clear, children, for everyone? Akila? Simran? Good. Okay, good, good, Aditya. Now I ask Akila to present. Akila, show me. Akila, show me. Turn on your video, beta. Ayush, what happened? Akash, Ayush, Akshat, Taman, you people are not doing. Did you understand or not? Have you got my point? The truth table. If you did not understand, I'll explain. Akila, are you presenting?
Yes, ma'am.
Yeah, just turn on your video. Not visible, child. Okay, Simran.
Yes, ma'am.
By then, Akila
I'll
gets
show.
ready. Yeah, Simran, show me. Dhruv, what happened? Completing. Still, truth table. समझ में आ गया कि नहीं ध्रुव?
मैम समझ आ गया.
हाँ, तो कर देना. Harsh was so quick in the previous class. What happened today, Harsh? Keith Kaur?
Yes, ma'am. Ma'am,
हाँ. बताओ हर्ष.
मैम लास्ट तक प्रूव नहीं होता मैम.
Okay, see. Yeah, as others are taking time, so I will once again show you. See, children, it's very simple. First, you have to make all the combinations. X, Y, Z. See, X, Y, Z are the variables. So, 3 variables combinations. 0 से शुरू करके 7 तक आएगा. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. ठीक है? Then same thing with the 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. हो गया 8 combinations. क्रॉस चेक कर दिया अपने नोटबुक में. सो पहले एक कॉम्बिनेशन रेडी हो गया तो okay ma, so then it is easy for us to see. Now what do you want? First bracket का तो पहले इवैल्यूएट करेंगे ना, जैसे मैथमेटिकल एक्सप्रेशन कुछ भी है तो हमारे पास. So ओके, सो देन y प्लस जेड हमको चाहिए तो y प्लस जेड का कॉलम बनानी है. देन x एंड y प्लस जेड कर सकते हैं तो x एंड y प्लस जेड कर दिए. नेक्स्ट एक्स वाई चाहिए तो एक्स वाई कर दिए. एक्स जेड चाहिए देन ओनली वी कैन मेक एक्स वाई प्लस वाई जेड एक्स जेड. ठीक है, सो लाइक दैट. फॉर दिस नाउ यू टेल मी, सो व्हाट शुड आई राइट हियर फॉर दिस सेकंड एक्सप्रेशन. एक्स प्लस वाई जेड में पहले वाई जेड इवैल्यूएट करना है. ठीक है ना बेटा, समझ में आ रहा है सब लोगों को बच्चों? ठीक है, सो वाई जेड के बाद हम तो एक्स प्लस वाई जेड कर सकते हैं. ओके चिल्ड्रन, सो देन राइट साइड एक्सप्रेशन इफ यू सी एक्स प्लस वाई and then we need x plus z, then only we can make out x plus y and x plus z. Yes or no? So now do not look at these other columns, only x y z column you look into and now you find out these values. Okay ma, so for this much only we should find out. Right, now yz you people tell me 0 and 0. See, you see corresponding row 0 0. yz कितना होगा बताओ? yz how much? 0. Next 0 and 1 0. 1 and 0. 1 and 0
Zero.
0. 1 and 1 1. Next 0 and 0 0. Then 0 and 1 0. Only yz का कॉलम देखना है. 0 and 1 0. 1 and 0 0. Then 1 and 1 1. ठीक है, now x plus yz. So x का column you have to look into this first column and now whatever evaluated now, that much only you should look into. Okay children, so now x plus yz. अब x वैल्यू कितना है बताओ? 0 and yz वैल्यू कितना है? 0. so x plus yz कितना होगा? 0. x plus yz 0 plus 0 0. Next 0 plus 0 0. Next 0 plus 1 1. Next 1 plus 0 1. Next 1 plus 0 1. 1 plus 1 1. Next 1 plus 1 1. Next 1 plus 1 1. हो गया? So now x plus y कर देना. So now only you have to look into x and y columns and find out this. So x value 0, y value 0 0. 0 plus 0 0. 0 plus 1 0. 0 plus 1 कितना है? 1. Very good. हाँ, प्लस बेटा प्लस प्लस एडिशन होता है. ठीक है ना? 0 plus 1 1. 1 plus 0 1. 1 plus 0 1. 1 plus 1 1. 1 plus 1 1. Now x plus z, मतलब x कॉलम को देखना है, z कॉलम को देखना है, y कॉलम को नहीं देखना है. ठीक है, now 0 plus 0 0. 0 plus 1 1. 0 plus 0 0. 0 plus 1 1. Next 1 plus 0 1. 1 plus 1 1. 1 plus 0 1. Next 1 plus 1 1. Now इन दोनों को AND करना है. ठीक है, 0 and 0 is how much? 0. 0 and 0 is how much? 0. 1 and 0 is how much? 0. And 1 plus 1 and 1 1. 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 So now if you look at x plus yz, okay, so this is the LHS of the second expression, isn't it? So x plus yz, and then the x plus y and x plus z. Are they both same or not? Tell me.
Ma'am, which two, ma'am?
Which two? This LHS and RHS columns. For the second expression, what is LHS?
X plus YZ.
Oh, very good.
Yes,
What is RHS?
X plus Y into X plus Z.
Correct. So where are those two columns? This one which I highlighted and the last column. Right? So now you should see only these two columns. And
Ma'am,
are
both
they
are same,
same?
ma'am.
Triple Z, triple zero, and then 5 ones. Here also triple zero, 5 ones. Okay. So then you just encircle it and then mention hence proved. Are you all done? Okay, this column and this column. Okay, children. See how I have highlighted, no, that way. You write in your notebook, encircle karke, these two are same. Now I'll take a different color because that another one is a different theorem. Is okay, another part of the theorem. Okay. So this column and this column. Got it, children? So these two must be same and these two must be same. So this orange color highlighted one is first part of the theorem and second one. So all together, two parts of the both theorem we proved in the same table. Now quickly do that for absorption theorem. एक वेरिएबल को absorb करना है ना. So now prove absorption theorem using truth table. Do it, children. Prove absorption theorem. Have you all noted down absorption theorem? Okay, prove absorption theorem. Here it is there, you can see. Prove absorption theorem using truth table. Now quickly do that. So how much time you need?
Ma'am, done.
Yeah. How many of you completed?
Ma'am, done.
Show me, turn on your video and show me. Only 5 people are doing. What about others, ma? Ayush?
Ma'am, I'm doing in the PPT only, ma'am.
एक पीपीटी में मत करो यार, नोटबुक में करो. नोटबुक में करके see in your periodic test also what you do know. If you are doing in PPT it will take long time. Okay, नोटबुक में फटाफट करके फोटो खींच के डाल देना, ठीक है?
Yes, ma'am.
हाँ, so it will take time, beta. See, as I have to show you, I'm doing in the PPT. Okay, quickly do it in your notebook and show me. Akash, Akshat, Akshit, अमन, अनीश, आप लोगों को समझ में नहीं आया क्या? अनु,
I'm done, ma'am.
so how many of you have done? Raise your hand. Only 5 people raised hand. Dimple, turn on your video and दिखाना बेटा.
Ma'am, I don't have my test now.
You logged in from PC. Okay. So you can take a snapshot and share also, no problem. Ashwant, turn on your video, beta.
Ma'am, but I am in a PC, ma'am. So
No problem. So if it is wrong,
Can
I
you
will
show the second?
explain now,
it's
beta.
not available. It's not available, so I didn't raise my hand.
Which is not available.
Camera is not available.
Camera is not available. Okay. Mobile. Yeah. So now who is ready to show me?
Ma'am, can you show the second?
Ma'am, I have proved the first part, ma'am, the x plus xy equals x.
Very good. Second part also in the same truth table you can complete.
Yes, ma'am.
Ma'am, what is second part, ma'am?
Dual of the given expression. Dual कैसे पता चलेगा? डॉट को प्लस करो, प्लस को डॉट करो, 0 को 1 करो, 1 को 0 करो, ड्यूअल मिलेगा. किसी को डाउट है इसे प्रूव करने में? If anyone is having doubt, you can ask me, children.
I'm done, ma'am.
Yeah, blueprint also I have shared with you people, isn't it? Periodic test
Ma'am,
one
can you
also.
tell?
Sorry?
Ma'am, I've made you true table.
Okay, okay. So always true को क्या बोलते हैं? The expression which evaluates to always one, whatever may be input, whatever the combination. What do you call that expression?
True.
True. Which is always false?
Zero.
Fallacy. Fallacy. Output is 0. That statement को बोलते हैं fallacy. Okay.
Fallacy.
Fallacy. Fallacy. Okay, माँ समझ में आ गया? Fallacy
Yes,
is always false. Whatever you give. Okay. Give me one example for fallacy. Always 0 आना चाहिए.
Ma'am, 0, 0.
X dot X dash is how much? X dot X dash is how much? Always 0, na? So, if you are taking X and X dash, always it is 0. Otherwise, yeah, truth table of X and X dash. So, simple one I am showing you. Yeah, so some expression and it's by applying De Morgan's theorem, you can get the complement of that expression, no? So, then that also you will get a fallacy always. Got it, children? So, here I'll show you. So, only X ka value 0 or 1 only, isn't it? We are not having only, we are not having two variables here. We are having only one variable in this expression, right? So now इसका complement होगा. What is the complement of 0, 1? What is the complement of 1, 0? Now X dot X dash. Tell me. Always. This is X dot X dash. So 0 and 1 is 0. 1 and 0 is 0. Okay. So this is the expression which always result in false. 0. Output is 0. Whatever may be input. Then it is known as, what do you call it? What do you call, children? That expression?
Fallacy.
Fallacy. Okay. Always true को क्या बोलते हैं?
Truth.
Tautology. Always true. The expression which is always true is tautology. Okay, ma. The expression which is always false is fallacy. Okay. Now hope you all understood the truth table. Now let's draw logic circuit. This truth table is everyone has written in your notebook. Everyone completed? Yeah.
Yes, ma'am.
This is who has given this one, X and X plus Y. Yeah, this is Ayush you have done.
Yes, ma'am.
This is who has done this slide.
I didn't send you, ma'am.
Ayush N has done here.
Yes, ma'am. But I didn't send you.
No, you have done in the same PPT, no, which I am sharing.
Oh.
Got it, children? So like Google Sheet, how I am sharing, not the same manner this PPT is shared with you. Okay, see, I can see you. Ayush has done here this slide. Okay, yeah. So this is absorption theorem. This much only. So here title I am writing absorption. Proof of what? Absorption using truth table. So if you want to do any changes, no, children, you download it and do it on your desktop. Okay, if you don't want to do changes to whatever I have shared. Okay, beta. So these are all don't want, right?
Excuse me, ma'am.
Yes, ma'am.
Ma'am, suppose if a question is asked like state and verify absorption law, should we draw the truth table also?
Yeah, state and verify मतलब verify कैसे करोगे? कैसे करोगे? Using truth table only, na? Verify means proof only.
Ma'am, so that will be enough.
Sorry?
So stating the law and drawing the truth table will be enough, ma'am?
Correct. See, this is the statement. After drawing the truth table, encircle LHS and RHS. But this is only one part of it, right? What about the other part? Ayush?
Ma'am, both are there only, ma'am. The red part.
That
Red
is
part.
LHS and RHS, right?
Yes, ma'am. Of
Okay,
both
fine,
the
fine,
theorems,
fine.
ma'am.
Yeah, all of them are equal to, yeah. X. Okay, so you have to encircle, no? Okay, this much only. And then what do? You highlight those. See, this is X. Okay, ma'am. And then this is X plus XY. Okay, Y is absorbed. And then this is X and X plus Y. Okay, star nahi chahiye, dot only. Done. Now, let us draw one circuit diagram also. Then we will wind up this NAND gate we will go to. Okay. So, let us draw a circuit for distributive theorem. No, absorption theorem only. So, here, logic circuit. How to draw? X plus XY. See, now let us draw. How to draw, children? We need one X variable. Okay. X, and we need one Y. So what you can do is one. So first let me take vertical lines. This is X line, children. What is this line? X. Okay, now I am taking another vertical line, that is Y. Okay, ma. So two variables, hai na? So from these two lines only, I will connect to my integrated circuit. So finally, see, first I need on AND gate. And is similar to D, no, D shape. Okay, so from Yeah. So from here, this is from Y. This is Y line. Okay. So from Y, and then I need one from X. So this will be XY. Got it, children? And then we need one. Which gate? Another gate is, what is the other gate? Tell me, children. What is the other gate? OR gate, no?
Yes.
Yeah. So perfect D shape is there. Yeah, this is what we wait. Yeah, this is the AND gate. Okay, and then insert one OR gate. Somewhere that shape is there, children. I'll take this shape. Okay, this one I'll take. Okay, so from X we need another line.
Ma'am, can you label the lines?
We'll label now. Yeah. X से एक आ गया, then we need another one from okay. So now final output will come. Got it, children? So now quickly you can draw in your notebook. So now you can see. Now let me label them. So this is X now. Then this is, what is this? What is this line, children? Y. Okay. Now ये हो गया आपका X. X से कनेक्शन ले लिया ना, ठीक है? And then ये भी X हो गया. ठीक है? Next ये हो गया आपका Y. ठीक है? So next this is X and Y. Okay, then finally what did you get? This is, what is this, children? X plus XY. Got it? X plus XY. So now if you look into this, why we should learn these theorems? Now इतना मुश्किल से हमने सर्क्यूट बना दिया. सर्क्यूट बनाने के लिए हमको वायर्स चाहिए, and then we need to buy these integrated circuits also. Yes or no? So if you know the theorem, instead of these many gates, see one AND gate, one OR gate, and one XY inputs, instead of all these things, instead of this, what you can do, directly you can give connection from X. Yes or no? So that is the main advantage of learning theorems, children. Is it clear to everybody? You must be thinking why we should learn all this math like that. Okay. So why we should learn? It will reduce the complexity of the circuit. So जहाँ पे हमारा expression इतना बड़ा बड़ा, see now we are doing simple equations, isn't it? So if the expression is very big expression, and there wherever we can simplify, wherever you can replace. No, this much big circuit can be replaced with a single wire. Got it, children? So similar way you can draw x dot x plus y equal to x also. Okay, similarly you can take from the same vertical lines. X say y say Okay, children, is it clear? Understood? So this is how you will be drawing a logic circuit for the given expression. Quickly, you will be doing in your notebook and taking a snapshot and uploading for your answers if it is asked in the question paper. Right? So blueprint में आप देख लीजिए, see 2 marks for the true table, 2 marks for the circuit, 2 marks for the all these things are there. So you have to quickly draw. If you are wasting your spending your time to draw online, no, then what will happen? So you will take long time, right? So quickly you have to do like this, children. Got it? Now let's quickly proceed to NAND, universal gates. There are two gates which are known as universal gates. What are those two gates, you know, children? One is NAND gate and another one is NOR gate, right? So here, these are the two universal gates. What are the two universal gates? Tell me. What are the two universal gates? NAND
Ma'am,
gate
NAND
and
and
yeah,
NOR gate.
NAND gate and NOR gate. Okay. So NAND, why NAND and NOR are known as universal gates? Anyone can tell? Do you have idea? If you do not have idea, I will tell. No problem. Okay. So why we call them as universal gates? You know, if one gate is there with us, that is NAND gate alone we have. Only we know that configuration only. Okay. Using that NAND gate alone, we can draw NOT gate, we can draw AND gate, we can draw OR gate. Okay, children. So that means we can represent all the three operations. How many operations we have? Only three. And or not. And then all the combinations only. Right. So all the three operations can be done by using NAND alone. By using NOR alone. That is the reason we call NAND gate and NOR gate as universal gates. Okay, children. So in the previous class, I have shown you, what is the NAND gate? How does it look like? A bubble must be compulsory. So now let us represent. Draw NOT gate using NAND operation. How do we do that? हमारे पास सिर्फ NAND गेट है, ठीक है. सो व्हेन हमारे पास सिर्फ NAND गेट है, तो how do we draw NOT gate? Okay, children, so here I go. So I'll first which gate we will do? NAND gate we will do. Okay. This one all don't want. Yeah. So now first which one we are representing, children? Tell me. NOT operation. Okay. Using NAND gate. See, हमारे पास NAND gate है तो मतलब क्या है? यूनिवर्सल गेट. यूनिवर्सल गेट मतलब हम कुछ भी इससे रिप्रेजेंट कर सकते हैं. So now I'll first draw one NAND gate. बबल इज कंपलसरी चिल्ड्रन. एन आ गया मतलब बबल होना चाहिए. ठीक है. Okay, now we need to draw. Right, so insert. I'm inserting one two straight lines. तो टू इनपुट NAND गेट. मान लीजिए हमारे पास टू इनपुट NAND गेट है. ठीक है. तो मतलब इट विल टेक टू इनपुट्स एंड देन वन आउटपुट. Okay, this is the NAND gate. So अगर if my input is A, I should get A dash. Not में क्या आना चाहिए बताओ? In the not operation, that is negation, right? Yes, ma'am.
Not operation, you'll get you keep get A dash. And operation, keep A and B.
Yeah. So
You'll
now
get
what we are doing not only, right? Not operation only we are doing. Not operation. So not matlab if A is the input, what must be output? What must be the output? A complement is the output. A dash is the output. Right. So now हमारे पास इसमें देख लेना. So now हमारे पास A भी है. ठीक है. A dot B का whole complement आ रहा है. So NAND मतलब क्या आ रहा है? A dot B का whole complement आ रहा है. मतलब as per De Morgan's theorem, what is this? A dash dot B dash आ रहा है ना? So this is as per De Morgan's. Yes, ma'am. Okay, this much is clear. As per De Morgan's theorem, what are we getting? From the NAND gate. NAND मतलब एंड का कॉम्प्लीमेंट, सो ए डॉट बी का कॉम्प्लीमेंट आ गया, लेकिन हमको चाहिए सिर्फ ए का कॉम्प्लीमेंट, तो हाउ डू वी डू दैट? सम idempotent theorem is there na, a dot a is how much, children tell me? A dot a is how much? Idempotence, children, you should be thorough with theorems. A potential, so b के जगह पे भी हमने a को ही कनेक्शन किया, तो क्या मिलेगा आपको? ये कॉम्प्लीमेंट मिलेगा या, सो बी के जगह पे अगर हमने ऐसे ले लिया तो मतलब क्या है, हमको ये कॉम्प्लीमेंट ही मिलेगा, हमको आउटपुट यही मिलना चाहिए ना, ठीक है, नॉट का मतलब यही चाहिए ना, तो बी के जगह पे क्या लेना है? सो okay, so what should we do? So replace or connect both inputs to A to get not result using NAND. हो गया? अब क्या करना है बताओ? ये दोनों इनपुट को किससे कनेक्ट करना है? सिर्फ एक ही इनपुट से कनेक्ट करना है, आगे समझ में? सो मान लीजिए ये हो गया हमारा ये, ओके, सो उसी ए से हम कनेक्ट किया तो काम खत्म। हो गया चिल्ड्रन? आगे समझ में? yes or no? So only one input is given, so a dot a हो गया इधर, ठीक है, a dot a मतलब ये ही हो गया, उसका कॉम्प्लीमेंट हो गया, आउटपुट क्या आएगा? ये कॉम्प्लीमेंट आएगा कि नहीं? डन? किसी को डाउट है तो पूछ सकते हैं। If anyone is having doubt, you can ask.
Ma'am, can you repeat?
बट एक्चुअली NAND गेट में दो इनपुट होता है ना, सो ये और बी होता है, ठीक है, सो इंस्टेड ऑफ ए एंड बी व्हाट एम आई डूइंग, इसी ए को दो बार मैं दे रहा हूँ, मतलब क्या है, ए डॉट ए होगा पहले, डी मतलब डॉट है ना, सो ए डॉट ए कितना होगा एज पर द थ्योरम? ए डॉट ए ओनली, तो इसका बबल, बबल मतलब कॉम्प्लीमेंट, सो ए का कॉम्प्लीमेंट क्या है? जो आउटपुट हमको चाहिए वो आउटपुट आ गया कि नहीं? सो नॉट गेट में ये इनपुट दे दिया तो ये कॉम्प्लीमेंट आउटपुट आना चाहिए, सो वो आ रहा है कि नहीं?
Yes, ma'am.
Got it? So this is how using NAND we have implemented NOT. Using NAND, NOT operation is implemented or not? आगे समझ में? ठीक है, this is NOT operation using NAND. Next, we will do AND operation. अब क्या करना है? AND, ओके, AND गेट का इंप्लीमेंट करना है, ठीक है। AND में क्या करेंगे? ये भी इनपुट्स होगा, आउटपुट क्या चाहिए? आउटपुट क्या होगा बेटा?
A.
AND में
B.
हाँ, ए बी हमने इनपुट डाला तो आउटपुट क्या होना चाहिए एंड में?
A dash B dash.
ए डैश डैश कहां से आएगा? एंड ऑपरेशन बेटा, नॉर्मल एंड, फॉरगेट अबाउट NAND, AND gate. In the previous classes we have done.
A dot
Very good. So इसके लिए क्यों इतना तर्जन बर्जन हो रहा है? ठीक है? So if A, B are the inputs, A dot B should be the output. Okay. So that is A dot B must be output. Okay. If A, B are the inputs. Right. लेकिन हमको ये NAND गेट में क्या हो रहा है ना, डायरेक्ट हमको इधर क्या मिल रहा है, ये डॉट बी का होल कॉम्प्लीमेंट मिल रहा है. हमको कॉम्प्लीमेंट नहीं चाहिए. अगर हमने इधर बी का इनपुट दे दिया, ठीक है, तो दिस इज बी. ओके चिल्ड्रन. सो नाउ ये भी ऐसे दे दिया तो व्हाट आर वी गेटिंग हियर, ए डॉट बी होल कॉम्प्लीमेंट मिल रहा है. लेकिन हमको चाहिए ए डॉट बी. कैसे मिलेगा ए डॉट बी? Anyone? You're all very good brainies, no? So you just give me an idea. ये तो मुझे कॉम्प्लीमेंट मिल रहा है, बट वी नीड ए डॉट बी. कैसे मिलेगा? How to get it? So if you once again complement A dot B, what do we get, children? Tell me. Complement of complement is x complement whole complement is how much? X complement whole complement is involution theorem. X. What is the theorem?
Double
Involution
involution.
theorem. Yeah, that is involution theorem. So already हमारे पास एक कॉम्प्लीमेंट हो गया, इसको फिर से कॉम्प्लीमेंट कर दिया तो ये भी आएगा ना. फिर से कॉम्प्लीमेंट करना मतलब क्या करना है, फिर से उसको इसको ये इसमें पास करना है. ठीक है, नॉट ऑपरेशन करना है ना. फाइनली जो रिजल्ट आ गया उसको हमने क्या करना है, फिर से नॉट करना है. ठीक है, नॉट ऑपरेशन में भेजना है. ठीक है. So now what am I doing? This entire thing I'm taking. Okay. So here A dot B dash आ गया मेरे पास. ठीक है. So here I will do A dot B dash को मैं क्या करूंगी? So फिर A dot B dash को भेज दूंगी इस गेट में. Okay, आ गया. Now you can see. Got it, children? So final output क्या होगा? A dot B dash को हमने फिर से NAND में भेज दिया तो क्या होगा? Children, you are not responding. Yeah.
A dot B.
A dot B आ गया. तो हमको जो चाहिए वो आ गया कि नहीं?
Yes, ma'am.
Yes, ma'am.
Yeah. So somehow my lines are not straight, but you can okay, adjust it. Yes, ma'am.
Ma'am, if we pass any input from this semicircle, ma'am, then it will become negotiation, ma'am.
Which one?
Ma'am, like if we pass any input from the semicircle, ma'am, then output will be the negotiation of the input.
Semicircle मतलब NAND gate. You mean to say?
Yes, ma'am. Yes, ma'am.
NAND gate से जो भी भेजेंगे तो क्या होगा? फिर से बताओ.
Negotiation.
Negotiation मतलब?
Ma'am, involution.
हाँ, sorry.
Ma'am, involution.
Negation, not negotiation. Okay.
Sorry.
Okay, it's okay. Negotiation मतलब bargain में होता है ना, market में. So plus or
Yes, ma'am.
minus. Okay. So okay, बेटा. Yeah. Yes, ma'am. समझ में आ गया? नाउ और का इम्प्लीमेंट कर देना क्विकली. Now you implement OR operation using NAND. If you understood, children, this much. So now quickly you implement OR operation using NAND. थोड़ा सा दिमाग. हमको आउटपुट आना चाहिए. You should get an output of A plus B. Okay. So here this is AND operation we have implemented. Now we should implement OR operation. OR operation, how do we get? By A plus B we should get. So NAND का output आएगा A dot B का whole complement. That means A dash plus B dash. ठीक है. But हमको चाहिए what are we expecting from this?
A plus B.
A plus B चाहिए. So ये dash की जगह पे हमको ये चाहिए. B dash की जगह पे हमको B चाहिए. That means wherever input we are giving, if you give input A dash here. Okay, here if you give input B dash, then what do we get? A dash B dash का whole dash.
A plus B.
Yes or no? So A dash B dash का whole dash मतलब क्या है? A dash B dash का whole dash मतलब क्या है? If you expand it, De Morgan's theorem, A dash dash plus B dash dash. A dash dash मतलब क्या है?
A, ma'am.
Very good. So that is A and B dash dash मतलब B. आ गया हमको जो चाहिए. So पहले इनपुट में क्या डालना है बताओ. So this and all is not needed then. Okay, children. So this is not needed, na?
No, ma'am.
No.
OR gate we need, ma'am. OR gate we need, ma'am.
OR gate कहाँ से है? See, OR gate is not at all there with us. We have only NAND. Universal मतलब क्या है? हमारे पास दूसरा गेट कुछ है ही नहीं. वैसे सोच के करना है, ठीक है?
Ma'am.
Yes, ma'am.
Can we make like this, ma'am? Like input is A and B, then we will get A plus B negotiate, and again we will do, then we will get A plus B, ma'am.
No, A plus B कहाँ से आ गया बेटा? हमारे पास A plus B है ही नहीं ना. इसी इसमें मतलब A dash B dash ऐसे आ गया मतलब ए डैश बी डैश का कॉम्प्लीमेंट आ गया हमारे पास, मतलब हमको ए प्लस बी मिल गया है ना, एज पर द फॉर्मूला दिस इज रेडी.
Yes, ma'am.
Yeah, for this what we should do, no?
Ma'am, A dash and B dash are fixed, ma'am. Input.
So here actually हमारे पास ये भी is the input, right? A dash B dash हमारे पास है ही नहीं. So पहले हमको इधर A dash देना है, तो पहले ये को क्या करना है, A dash बनाना है ना. So ये हमारे पास है, तो A dash बनाना आता है कि नहीं, नॉट गेट यूज करके?
Yes, ma'am.
आता है ना. So आप ये इसको पहले क्या करना है, वो NAND करके पहले A फाइंड आउट करना है. सी अब A डैश आ गया, वैसे B डैश को भी पता कर दो. कर दिया बच्चों?
Yes, ma'am.
अब इसमें क्या करना है, दोनों को जुड़ के एक लाइन में का सी आई विल शो यू हाउ टू ड्रॉ. Okay, I'll take one rectangle. Okay. Now this is nice, no? ओके चिल्ड्रन, अब आ गया, ये हो गया, ये इसका लेबल कर देंगे ए, इंसर्ट टेक्स्ट बॉक्स, ओके मैम, सो ये से ए डैश आ गया। सिमिलरली नीचे वाला क्या लेबल करना है बताओ?
B.
ओके,
Ma'am.
yes ma'am. So now you all understood. See, using NAND alone, we have implemented NOT gate, we have implemented OR gate, we have implemented. So this is OR implementation using NAND. Okay, so this is OR implementation using NAND. Okay, next this one is AND implementation using NAND. And then the above one is NOT implementation. NOT के लिए so आप कैसे भी wires को join करना है. So these lines are to indicate wires बेटा. ठीक है? So you make proper lines. We have done using NAND alone. So that is the reason this NAND gate is known as universal gate. Similarly, do as homework NOR gate के साथ करना. ठीक है? So now I'll stop here. Yeah, any other doubts ask me. So this Boolean algebra we have concluded here. In the next class I will be just revising the other topics. Yeah, binary, octal I have already explained you during this Boolean. But once again, I'll just quickly, ASCII is key Unicode difference. ASCII also I have explained you. And then, yeah, quickly we will be revising in the next class, whatever to be